Hi everyone, we're going to integrate this question by using partial fraction. So first of all, we need to express our fraction in partial fraction form. First, this has to be a proper function. As you can see, this is constant. Down here, when we expand, we have cubic. So this is proper. Secondly, we have to make sure our denominator can be factorized completely. For x squared plus 2, we try to factorize whether you can get 2 factor. So as you can see, when you press calculator, you have a imaginary unit come up. So which means that this quadratic cannot be factorized anymore. So this is a quadratic factor. Then we're going to split according to the factor of linear x, and another one is x squared plus 2. So for a constant x, for linear x, we need a constant up here to make sure it is back to the proper fraction. Then for quadratic, denominator up here will be a smaller function, which is a linear. So up here is a bx plus c, linear. So down here is a quadratic. So after we identify this ABC, we're going to get same to the denominator, where a will multiply with the factor it don't have, which is x squared plus 2. And bx, we put in bracket so that it multiply to x. If you don't put in bracket, it will become bx. Then c times x. It will make us misunderstanding. So then the next part, we're going to start let. As we can see, we have three unknown here. We need to let it 3 times to find out this ABC. So we can let it from the roots here. As we can see, we don't have roots here. So one of the root is x. So x equals to 0. And then other one, we need to use simultaneous. So we let it first. We find out 1 first. So substitute x is 0. It gives us 2a. And then a, you can get this is 3 over 2. So another one, if you want to let, we'll come to a simultaneous equation. So if you want to avoid simultaneous equation, we can choose another method, which is expand and find out, then compare the coefficient. So as a is 3 over 2, x squared plus 2, and then this is bx squared plus cx. We can try and expand and compare to find out the other unknown. So this is 3 over 2 x squared plus together with bx squared, and our linear is cx. This constant is plus 3. So for x squared, you will have 3 over 2 plus b, then linear is cx, then plus 3. So as we compare, so linear don't have, so which means that cx, c is 0. And then quadratic, do we have quadratic term at here? We compare at the left hand side, we don't have, which means that 3 over b, 3 over 2b, 3 over 2 plus b is equal to 0. So b will be equal to negative 3 over 2. So finally, we need to rewrite our partial fraction. So a is 3 over 2x, b is negative 3 over 2x, c is 0. And when I rewrite the coefficient, I move the denominator of 2, I move together with the denominator x squared plus 2. So in this case, we are continue integrate this fraction in its partial fraction form. So from here, we can see we can factorize 3 over 2. So inside, just integrate 1 over x minus x over x squared plus 2 dx. So this one we can use formula of 6, which is fraction. But for this one, we have to check whether we have special form formula. So special formula will be integrate fx f prime x, number 6, it gives us dx. It will give us ln fx. So we try to have a check here. Fx denominator is x squared plus 2. Differentiate this, denominator is supposed to get 2x, so we can alter this while multiply this as 2, and the coefficient out here divide by 2 become 1 over 2. Therefore, when we want to integrate this, it will give us 3 over 2. Integrate 1 over x is ln x. We put modulus to make sure the ln function here is valid for all the positive function. Then coefficient is 1 over 2. Inside here is ln x squared plus 2. And then plus c. Alright, so this is our, as you can see, this is our fx. Up here is our f prime x. Alright, so we have this pattern. So when we have this pattern, we can directly integrate using our special form formula. So our last step, we're going to simplify this. So 3, we can take out 1 over 2. So when we take out 1 over 2, it will become 3 over 4. So take out 1 over 2, here we have a coefficient of 2. So divide. When you take out 1 over 2 means I divide with 1 over 2. Divide with 1 over 2, we have constant 2 here. So I want to make it ln minus ln, not any constant in front here. And these two we can use properties of logarithm, move it as a power. So we can get 3 over 2 ln x squared, ln minus ln, it will be in division. So lastly, plus c. So that's all for this question. Thank you for watching.